In this video, let's talk about how to do video-audio synchronization in a media player. We call it AV-Sync for short. I think AV-Sync is a special task for media player. AV-Sync is an essential task for any media player. There are many ways to do AV-Sync. Let me show you one of the simplest way. Render the audio date continuously and record the PTS of the last audio frame you just pushed into the audio renderer. Get the difference between the PTS of the video frame you are going to render and the audio PTS you are recorded in step 1, and use an algorithm to decide when to render the video frames. It's over. Yes, it's simple, but it's effective for most cases, but not cases. But if you want to make a professional media player, you shouldn't use this way. It has many problems. Let me show you the major issues. Every audio renderer has internal cache buffers. The data you put into the renderer can't be rendered immediately, so the PTS value is faster, and the offset is not a fixed value. If you take the PTS of the audio frames as the clock of the video, you will get a low precision clock. The precision depends on the duration of the audio frames, and the low precision clock will lead to video frame droppings and jitters. Using your media player to play a sports video on a large size screen would be inaccessible. As a professional media player, it should not only play a video, but also play well. The picture quality is a vital performance, so you should figure out a method to keep AV-Sync and keep the video playing smoothly at the same time. Okay, let me show you how the Cicada player does AV-Sync. First, let me show you how to determine the audio clock. Every audio renderer has a way to let you know how many audio samples were consumed by now. Some use a callback function, some provide an API. The result of the sample count divided by the sample rate of the audio is the origin audio clock of the audio render. Here we call it audio pulse. The audio clock is the sum of the first PTS of audio and the audio pulse. By now, we've got a correct audio clock, and also you should handle some PTS abnormal cases. We will talk about it later. I should say, this is also a low precision clock, and the precision depends on the single buffer size of the internal buffer queue. On some platforms, you can set the value, the size, like iOS. On some platforms, you can't, like Android Audio Track. The smaller the buffer size, the higher the precision, but lower the performance. So there is no way to get a higher precision by a smaller buffer size. So we can get a correct but accurate audio clock here. We should figure out another way to get a high precision clock. Before talking about how to get a high precision audio clock, we should talk about another subject. There is no absolute synchronization, only relative synchronization. Actually, absolute synchronization is unnecessary. Otherwise, we can't build a media player on a general purpose operating system. and most operating systems are general purpose. There is no significant impact for a human when the offset between the video and audio is smaller than 200 milliseconds. So we can take another high precision timer as the audio clock. We call it the master clock here. And we can resync the master clock to the audio clock when necessary. If the offset between the two clocks is more than, for example, 100 milliseconds, we set the master clock to the audio clock. The value of the offset should be bigger than the precision of the audio clock and smaller than 200 milliseconds. And we don't want to be resynced frequently. And consider the CPU schedule period. I think 100 milliseconds is a more applicable value. If there is no audio, the master clock is a free clock. You only set its value when stars, 6, and PTS abnormal cases. The video and the subtitles can sync with the master clock. To get the video playing more smoothly, Cicada player use a system vsync signal to consume the video frames, but this logic is not a part of AV sync.